Hi everyone, today's lesson is on how series and parallel circuits differ. So we know that in a series circuit, electrons only have one path to travel through. And because there is only one pathway, this means that current is always going to stay the same. Let's highlight this. Current is always the same at any point in the circuit. So if you measure the current at one load and it's, let's say, for example, 2 amps, then at the next load in series, it will also be 2 amps. And in the next load in series, it will also be 2 amps. So current is always the same at any point in the path. So if you know the current in one section, you know the current everywhere in your circuit. That is for a series circuit. What also holds true is that more resistance in a circuit in series means less current. And what I mean by this is if you have one lamp in a circuit, then there's very little resistance in that circuit. If you have 2 lamps in series, wired in series, then you're going to have more resistance because every load acts like a bump in the road, which slows down the current. If you have 3 lamps in series, even less current. So the more loads you have, the more resistance is in your circuit, which means the less current is actually flowing through it. So a path with more loads has less current. Okay, let's demonstrate how more resistors equals less current in a series circuit. So in my diagram on the left, I have 2 resistors wired in series. Those resistors are going to act as my loads. Total resistance in this circuit is 10 ohms. Total voltage at the battery is 10 volts. I'm now going to use Ohm's law to calculate the current in this circuit. So IT represents total current. So I'm gonna measure the current at the power source. So remember, using Ohm's law, that to calculate current, the equation is voltage divided by resistance. So I'm going to have 10 volts divided by 10 ohms, which is going to equal 1 amp. So I have 2 loads wired in series on the left, and my current is 1 amp. Okay, let's look at the second circuit here. We have 3 loads wired in series. Our total resistance is 15 ohms. And remember, when you increase the number of loads in a series circuit, you are increasing the resistance because there's more bumps in the road for those electrons to encounter, which slows the rate that the electrons can actually travel through. Total voltage, again, at the battery source is going to stay 10 volts. Let's see what happens to the current now. So current is equal to voltage divided by resistance. My voltage is 10 volts. My resistance is 15 ohms. If I take 10 and I divide it by 15, I am going to get 0, if I round it, 0.7 amps of current. So you'll notice more loads, less current. And that's because there are more, the loads are acting as resistors, they're slowing down the current, which is making it be less. Now let's talk about current in parallel circuits. So remember, a parallel circuit has more than one pathway for electrons to travel down. So there's more than one branch in your circuit. Remember from our talk about series circuit, current will be the same where there is one path. What's different now is that current will actually split up to go through multiple paths. So if there's more than one branch, your current is going to split up. Here I have one branch, here I have one branch, and here I have one branch. So there's 3 separate branches in this circuit. The question here is asking, what would be the current for this path right here? Well, I know that this is one pathway right here. So even though this load is showing 0.67 amperes of current, and this load is showing 0.33 amperes of current. This load must be showing 3 amps of current because that's what the reading is here, and it's going to stay the same while it's on one pathway. It's different when it's on separate pathways. It will stay the same within one pathway. Now let's talk a little bit about how voltage works. So remember, the power source, or the cell, the battery, converts chemical energy into electric potential energy. And remember, that potential energy is what voltage is. So the voltage starts at the power source inside that battery. That battery that produces voltage, and it gives every electron that leaves the power source a certain amount of voltage. Those electrons give their voltage to every load in a circuit that they encounter. By the time they finish moving around the pathway, they have no more voltage. They return to the positive end of the terminal where they get more voltage. They reboot and they're sent back out. So remember, electrons leave the negative terminal, go around the circuit, and return back at the positive. By the time they return back, they have no more voltage because they dropped off their voltage, their electric potential, to each of the loads in that circuit, and so now they don't have any more. So they return back to the battery, and the battery refills the voltage and then sends it back out. Because electrons have to give their voltage to every load in a circuit, that means in a series circuit where you only have one pathway for electrons to travel through, then the voltage coming from the battery has to be split, or has to be equally divided between all the loads in the circuit. So that means that voltage is lost as you increase the amount of loads in your circuit. And this is why when you add a light bulb in series, so if you have a circuit with one light bulb, it shines really bright. If you add another light bulb in series, then they both become just a little bit dimmer. And you add another light bulb in series, they become even less powerful. This is because voltage is now being shared between those devices, those loads, and you're losing voltage. So really what ends up happening is your voltage splits. And so your total voltage is going to come from the voltage at each one of your loads. So you could add up all your loads, all the voltage at each load, and you'll get back to your total voltage. Okay, let's see what that actually looks like in a series circuit. So I have a series circuit here with 3 resistors wired in series, one after another. There's one pathway for electrons to flow through. These resistors are acting as my 3 loads. So I see that at the power source, at the battery, I have a total voltage of 6. Okay, and now I know from what I just previously told you that those 6 volts have to be split between all the loads in this circuit. So I see that there is a voltmeter reading at my first load of 2 volts. I see that there's a voltmeter reading at my second load of 1 volt. If I take 2 and add it to 1, I see that there is a total of 3 voltage so far between these 2 loads. I am missing a voltmeter reading for this last load. I know the entire series circuit has to have 6 volts of electron potential difference flowing through it, which means I'm going to take my total, which is 6 volts, and I'm going to subtract the 3 volts that are already present from my previous 2 loads, and I'm going to see that there are 3 volts of electrical potential left over. And again, you can see how to calculate V3 here on the right-hand side. Total voltage is going to equal all the voltage at each loads added together. You can just take your total voltage and subtract the voltage from the loads that you know. So 6 volts subtract 2 volts subtract 1 volt is going to leave you with a grand total of 3 volts. So voltage is the total voltage is the sum of the voltage at each load in a series circuit, and current always stays the same. Okay, now let's talk about voltage in parallel circuits. So voltage in parallel circuits is the same on each branch of the circuit. So each path is considered a separate branch in a parallel circuit. We already know this. So let me just show you what this might look like. So here's, you got a 2-cell battery. Okay. So I have 2 light bulbs wired in parallel. The voltage, for example, if the voltage at this light bulb was 3 volts, it would mean that the voltage at this light bulb is also 3 volts. So voltage is the same on each path. Be careful though, if you have loads wired in series within a parallel circuit, then you have to be careful to not make them the same. They would then be added together because they would be considered a series circuit. For example, if I had a light bulb here, this pathway here, all the way around, that's one pathway, has 2 light bulbs in series. So you would have to be careful. This light bulb will not be 3 volts, okay, because these 2 light bulbs are wired in series to each other, okay? So just take note of that. Okay, so let's see what that would look like in the next slide. Okay, so look at the example that I have here on this page. I have a parallel circuit with 3 loads, right? So this is one load, this is the second load, this is the third load. They're all on a separate branch. This is one branch, 2, 3. I have nothing wired in series here. Everything is in parallel. How many paths does this circuit have? It has 3 paths. How many loads does each path have? It only has 1, right? There's one resistor here on this pathway. There's another resistor on the second pathway, and there's another resistor on the third pathway. So what is the voltage of each load? Well, even though I don't know the exact number, I know that it has to be the same because voltage will always stay the same on different branches of a parallel circuit. So I hope you noticed that the voltage is the same for each parallel branch. So voltage stays the same for parallel circuits when you have a load on a separate branch. And now remember, Ohm's law, which we learned yesterday, allows you to calculate resistance, voltage, and current for any load or source in a circuit. And so we can always still use this equation to calculate total resistance in circuits as well. Here's a quick summary of what we just learned. In a series circuit, current is always equal. Okay, so any point of the path, your current will be the same for every load. That's in a series circuit. Voltage in a series circuit is the total voltage is the sum of the voltage at each load. So your voltage is going to be added up by how many loads you have in the circuit. In a parallel circuit, your current is the sum of each load. So your current is going to branch off onto each branch, and so you're going to have to add up the current to determine the total current. Whereas voltage actually stays the same throughout your circuit. Okay, so let's do some practice here. This is a series circuit. So this is how you should be solving these. Figure out, is it a series or parallel circuit? First, in a series circuit, I know I is the same and V adds up. Okay, I'm always going to write these notes to myself so I remember. So if I know that current stays the same throughout the circuit, then if this has a total current of 0.5 amps, then that 0.5 amps is going to be the current at the first load, and it's going to be the current at the second load, and it's also going to be the current at the third load. It's the same throughout. This problem is asking us to solve for V3, so the voltage at the third load. Again, this is a series circuit, so that means that I is the same and V is the sum, meaning you add it up. So I know my total voltage is 8 volts. I have 2 volts here and I have 3 volts here. So I'm going to take my total voltage and I'm going to subtract what I already have. I already have 3 volts. I already have 2 volts. How much does that leave me with? Well, that leaves me with 3 volts left over. So my V3 is going to equal 3 volts in total. And again, I can add them up and make sure it results in 8 volts. 2 plus 3 is 5, plus another 3 is 8. That gives me the total voltage from the battery source. Here, this question is asking me to calculate the resistance at the source and at each resistor. So I will show you how to calculate the resistance at the source, and then you can work through the different loads if you would like. So remember, resistance is equal to voltage divided by current. And I know this because of Ohm's law, right? So as long as you know voltage and current, you can calculate resistance. So I know the total voltage is 8 volts. I know the total current is 0.5 amps. So I'm going to calculate the resistance here at the battery source. So I'm going to plug it into my calculator. 8 divided by 0.5 is going to give you 16 ohms. So your total resistance at the battery source is 8 ohms. I will show you one more calculation. Let's do the resistance here at the first load. So resistance is going to equal 2 volts divided by 0.5, which is going to equal 4 ohms. Right, and you can keep doing this as you go through these loads. So again, resistance is going to be 3 divided by 0.5, which is going to give you 6. And again, 3 divided by 0.5 is going to give you 6. Okay. Remember, as you increase the number of loads in a series circuit, resistance increases. Okay, now you can pause the video and you can practice on your own and then check your answer. I will do the solution right here. So this is a parallel circuit, which means voltage stays the same and current is shared. Okay, is the sum. This example is asking me for voltage. So voltage stays the same. So if your total voltage at the power source is 6 volts, that means that the voltage at this load on its own branch has to be 6 volts, and the voltage on this branch also has to be 6 volts because they are wired in parallel. They are on different branches. This example is asking you to solve for the current at the second load. So again, I'm going to give myself some notes. This is a parallel circuit. Voltage stays the same. Current is the sum. So that means you add it together. I know my total current here is 2.5 amps. My first load has a current running through it of 1.5 amps. So I need to figure out what the rest of the current of the second load would be to make this 2.5. So I'm going to take 2.5 and I'm going to subtract 1.5 from it. So if I take 2.5 and subtract 1.5, I'm left with 1 amp of current. So this load must have 1 amp of current running through it. And I can double check my work by adding them together. 1.5 plus 1 is 2.5. That is the total amount of current that the power source had to begin with. So I've done this question correctly. Okay, this question is asking us to solve the resistance for the source and each bulb. Remember, using Ohm's law, you can calculate resistance by taking voltage and dividing it by current. So for the power source, I'm going to do 6 volts divided by 2.5 amps. And I'm going to get my answer, which is 2.4 ohms. Okay, and then you would do the same thing here, except you would do 6 volts divided by 1.5, and you would get an answer. And you would do 6 volts divided by 1, and you would get an answer. Okay? Okay, this takes us to the end of today's lesson. Let's just summarize what we learned. Let's talk about a series circuit first. In a series circuit, current is always the same. Okay, so if you know the total current at the power source, then that current is going to be the same at each load in the circuit. If you know the current at one load in the circuit, then you'll know the total current, and you'll know the current at every other load in the circuit. Okay, current is always the same, it never changes. Voltage is the sum at each load. Okay, so you're going to take your voltage readings at each load in your circuit, add them together, and that is going to give you your total voltage. If you know the total voltage, you're going to take that and you're going to subtract it from the voltage readings of the different loads you have in your circuit, and you can find out any missing pieces that you need. In a parallel circuit, the opposite is true. So in parallel circuit, voltage stays the same at every branch, but current is shared. Okay. Email me if you have any questions.